Welcome. In this video, I'm going to help you determine for which values of x this series here is convergent. And to do so, I'm going to use the ratio test. So let's quickly recall. So with the ratio test, we're looking at the limit as n approaches infinity of the ratio of the nth plus 1 term with the nth term. We're going to call that L. And if L is less than 1, then the series converges. If L is greater than 1, the series diverges. Otherwise, it's inconclusive. Okay, so a sub n is equal to n factorial over x to the n, times x to the nth power. The next term, the nth plus 1 term, is n plus 1 factorial. Notice I'm just taking this n here. And wherever I had an n, I'm replacing it with an n plus 1. So now I'm going to have an x, and instead of writing an n here, I'm going to write n plus 1. Now let's go ahead and look at this limit. That is, the limit as n approaches infinity of the nth plus 1 term divided by the nth term. This is n plus 1 factorial times x to the n plus 1 divided by n factorial times x to the n power. Now, here's where we need a little bit of algebra work. And if you're not familiar with the factorial or you just forgot, which is fine, there's a ton of forget in the world, plenty of math out there to forget. So if you just forgot what it is, no worries. Let's just recall what a factorial is. N factorial is the product of n times n minus 1 times n minus 2, and so on all the way to 3, 2, 1. Here's an example. 4 factorial is 4 times 3 times 2 times 1, and that's equal to 24. So those of you young calculus students, if you haven't turned 24 yet, remember when that birthday comes up, it's not your 24th birthday, it is your 4 factorial birthday. All right, so now that we've established n factorial, what is n plus 1 factorial? Well, that's equal to n plus 1 times n plus 1 minus 1 times n plus 1 minus 2. I'm going to do one more times n plus 1 minus 3. And then I'm going to keep multiplying dot, dot, dot until I get to 3, 2, 1. And I think you can see what I mean by 3, 2, 1 here. Eventually, you keep subtracting and you'll get to 3, 2, 1. So let's simplify this. N factorial, n plus 1 factorial is n plus 1. Now, n plus 1 minus 1 is just n, times n minus 1 times n minus 2, and so on. Ooh, that is tight there. Let me resize. Bear with me. There we are. I've resized my little asides here. So if you notice, this here, this is just n factorial. That tells me that n plus 1 factorial is equal to n plus 1 times n factorial. Okay, so let's use that up here. So this is the limit as n approaches infinity of n plus 1 times n factorial times x to the n times x divided by n factorial times x to the n. And then I quickly just broke this up into the product of like basis x's with their separate exponents, n and a 1. Okay, so we have some things that cancel, and cancel, remember, that's slang in this case for division, because right now everything is being multiplied, and the opposite of multiplication, what undoes multiplication, is division. So let's cancel. Let's use our math slang here. X to the n's cancel because x to the n divided by x to the n is 1. Similarly, n factorials cancel because something divided by itself is 1. So we end up with the limit as n approaches infinity of n plus 1 times x. So here we're concerned with the limit of n. So x, I can pull this out. Furthermore, the absolute value is only around the x because we know n starts at 0, so we're not going to have a negative n plus 1. So I don't need an absolute value here. X can be anything though, so it might be negative. Well, this limit here, no matter what, well, almost. Just a little caveat here, almost no matter what. This part is, we're going to diverge because this limit is infinity. I should be more specific. This here, this is infinity. So this power series will diverge everywhere except when x equals 0 here. This power series diverges everywhere except x equals 0. Okay, so what does that tell me? This tells me that my radius of convergence, r, is equal to 0, and the interval of convergence is just a single point of 0. All right, keep calm and calculus on.